I came up here to talk about a project of mine called Engulf, which is some advanced visualization. This is js.la. It's about half Clojure, half JavaScript. But I decided instead I'd rather show you guys how to make some awesome visualizations instead. So, are we switched over? Great. I want to start by showing you some of the great stuff you can make. Stuff like this force-based label placement, which I just looked up. I don't know what that really means, but it's really cool. We have charts like this amazing circle plot, where we can look at this API, we can explore, we can see the connections between different things. It's all JS and HTML, we can spin it around. If I grab it right. We can zoom out, we can adjust tension. We can do other awesome visualizations like this one. I don't know what's going on here. But this is all the same tool we're using to make all this stuff. We can build stuff like this FFT, this visualizer of frequencies. Right now we're looking at two signals at once. We're looking at one at 654 hertz and another one at about 6K. We can play around with stuff, do things interactively, move that, look at our waveform. And we can do things like real-time stats like this. This is the load tester I was mentioning previously. We're going to run 2,000 HTTP requests against a simulated slow server on our local host. And we're going to see results come back in real time for all of this. So the two technologies that are driving all of this, all the visualization in these cases is being driven by a tool called D3JS. You've probably heard of it. It's probably the best tool for building extremely advanced charts around. And the second thing that's really adding structure to our code, which I'll get to last in this presentation, is Backbone.js, which when you combine it with D3JS lets you build awesome visualizations with rather large amounts of code and still keep structure. So the title of my talk is now changed to the data-driven DOM. And the reason for this title is that it's about taking data, taking whatever you want to visualize, and driving plain DOM elements. That means all of the information you already have about using hold on one second, we got some feedback. All you already know about creating HTML documents can be reused to create exactly these kinds of diagrams. Some of those were using SVG, some of them were just using plain divs like you use every day. So these all have some similarities, these kinds of charts. Some of them involve real-time data, some of them involve stuff that's just tricky to visualize. I mean, if you go back to a chart like this, or like this chart, right? Like, Google Charts doesn't do this, you know? It doesn't do this. It doesn't do a whole lot of stuff. If you need to make a visualization from scratch, you're going to want some tools to help accelerate your development. And that's what D3 is here for. So, what is D3? Well, D3 is not a charting library. That's number one. It fits in a very specific sweet spot. It's about halfway between a charting tool and a drawing tool. If you've ever used Raphael, it's awesome. You get to draw lines in a cross-browser way, in a performant way. Great. But you want to draw a chart, you got to worry about a lot of details. You want to use something like highchart or Google Charts, you wind up constrained pretty quickly. If you don't want a bar chart or a line chart or whatever they give you, then you're kind of screwed. The other thing about all these things is that data is not the central thing to either one of these. To Raphael, the main thing it's concerned with is drawing primitives, which is really far from your data. You want something logarithmically scaled, well, Raphael doesn't really care. If you look at something like highcharts, I mean, it's not really about your data. It's about the data it wants. It's about you taking your data and transforming it into exactly what it wants, which is not what we need for extremely advanced visualizations like you just saw previously. And lastly, some of these tools aren't great at leveraging the DOM. Some of the stuff that use Canvas, try using Canvas to do interactive stuff. It gets really hard real fast. And the other thing about all these tools that a lot of them aren't built for is real-time data. Having data that changes, being able to look at stuff that comes from real-time stat sources is more important than ever now that we have things like WebSockets around. And the other great thing about D3 is it's not excruciating to use. It's really fucking hard, but it's not excruciating. Which is as good as you could hope for something like this. I mean, it has cryptically named methods, but that's only because you have to be a really weird genius to come up with this. I mean, the guy who's been doing this, Mike Bostock, he wrote an entire other full-featured visualization library. He's got 30 examples. The charts alone, just building them, probably took him weeks. He's a pretty dedicated guy, so we have to go into his mind a little bit to understand how this stuff works. So we already went through the examples. I did that out of order, but let's look at some actual D3 and understand how it works. So to start with, we're going to have to draw something very simple. We're going to learn how to draw a square. So this is not very exciting, it's a square, but it's the road to greater success. So this is going to look a lot like jQuery. So the only part of this document I really want you to look at is these two lines of JavaScript. These are going to drive this entire drawing. So the first line is pretty simple. We're selecting a div. We're selecting this empty div over here. It has an ID called viz. We're selecting or stepping in a variable. May as well be in jQuery right now. The second thing we're going to do is we're going to, this is currently styled as this red box right over here. We haven't gotten to the blue one yet. So we're going to add the blue box in. And the way we're going to do it is we're going to call append on it, much like you would in something like jQuery. I'm going to keep repeating that. And we're going to say we're going to append a div. And we're going to style it with a width of 200 and a height of 200. Right now, we have absolutely nothing over our standard DOM tools. But the point is we're going to be visualizing with the DOM. And we have the exact same tools we're used to do that. So let's get a little fancier than that. We're going to graph the Fibonacci series. From what I've read of programming textbooks, the Fibonacci series is very important. So I thought it would be a good thing to graph right here. And this is a really shitty graph of the Fibonacci series. It's not even scaled to the box, but it's really simple. That's the important thing. I didn't want to make it hard. I want to go in baby steps. Okay, so what we have here is we're only going to visualize part of the series. We're going to visualize this part of it. We're going to have a static array of that's our data set right now. So we're going to take this JavaScript array and we're going to put this on screen. We've already done it, but I'm going to walk you through the code. So each of these boxes is positioned kind of superfluously in an XY space, because it doesn't need to be XY, but why not? And each one is just positioned a number of pixels away as its value is. So like this one is 21 over and 21 down, and this one's 13 over, 13 down, etc. So let's walk through how this works. Well, we're going to start with the same thing again. We're going to select this empty red box called viz. We're going to select that right here. And then we're going to start drawing. Now, we're going to start talking, before we just drew stuff, now we're going to start talking about combining data and, we're going to describe what data we want, and we're going to draw it that way. So I'm going to walk through this code first in English, following these annotations over here, and then I'm going to describe how that works in code. So what this says is this is almost a declarative syntax. It actually really is a declarative syntax. We're saying within the scope of viz, that red box, and given that we're visualizing divs, this is going to be the weird part I'm going to come back to, this whole given thing. Using the following data, that's us inputting that array. Fibs is right here, it's that array. I can't point at stuff, I'm sorry, you're looking at that. When new data comes into our visualization, right here, append a div, and style its XY coordinates based on two functions. So let's walk back through that and understand what that really means. We're going to skip past select all. That's actually hard to describe without knowing the rest of it first. So the first part is really simple. We're just going to give D3 some data. You can't do anything with that yet, but that's going to come later. The next thing, enter, is really key to understanding D3. So D3's central metaphor is a stage. Like I said, crazy terminology. And the three things that an actor can do on a stage in the world of D3 is it can enter the stage, it can exit the stage, and it can also transition, move between different points in the stage. Since we're visualizing a static data set and we're going to render it once, we only are going to enter the stage once. We don't have new data coming in, we don't have data going out, we only have one set of data. So we're saying, okay, here's the rules for new data. The rule for new data is this. We append a div, and we style it like so. So one big difference from jQuery, these style methods right here, the second argument's a function. Let's look at that function, 2px. It's pretty simple. It takes a single argument and appends the string px to it. The reason it works that way is because there's a loop inside of D3, and it's continually going to render all the elements of the data based on all the elements of the data, and it's going to run them through this function to figure out what these top and left attributes to be. So for our last element, 21, the number here is going to be 21, and it's going to figure out that the top attribute is 21px down from the top, and the same thing for the left. So this is how the drawing works. Now, in our next example, we're going to understand this really mysterious thing here called select all, and that becomes more important when we add in the next dimension, time, the thing D3 is really good at. All right, so we are once again looking at time. Now we have more code. And by the way, to those of you who say, how come your editor doesn't syntax highlight JavaScript embedded in HTML? I mean, we all knew Emacs sucked, but I didn't know it sucked this bad. I say screw you, because Emacs is still better than your editor. But apologies for the lack of color. All right, so here we have a different visualization. We have a big red square, once again, and we have our Fibonacci series. We have an infinite series now, but this time we're seeing the data come in, once again positioned in much the same way, but this time when it comes in, it animates, it explodes out, which is kind of nice to watch. Let's see how that works, because that's kind of more complicated. I mean, if you wanted to build this with an existing charting tool, you'd pretty much be wind up stuck. You'd have to do this from scratch. So let's start again. The main thing to know is we now have more code. We have a function called render. And the rest of the code isn't important. What's important is that render gets called every second with a new Fibonacci number, the next one in the sequence. And what we're doing here is we're doing some housekeeping. We're holding onto an array. All your data in D3 is always in an array. And we're going to add something to it. So that array is just slowly growing. Every second it gets a new Fibonacci number on it. And we want to revisualize our data set with one more Fibonacci number added on. So once a second, this block of code is executing. So what's happening? We kind of do some of the same stuff all over and over again. We say, okay, we're going to be, given that we're visualizing divs, I'm going to get into this in just a second, I promise. And with our set of data, which may have changed, when new data appears, because still we only have new data coming in, we don't have data leaving yet, our array only grows, it never shrinks. Style it, much as we did before, with the top using that 2px function, and the left using the same. But now, when it comes in, when new data arrives, perform an animation. That's called a transition right here. And I've indented this really poorly, and I've indented it on purpose really poorly to show you guys the different contexts you switch through as you chain methods. You wouldn't probably write it this way, but it's helpful to learn that we're entering this data context, and we're entering the context of enter, then append, then the styles we're applying to it, then the transition here, and then all the stuff that happens during the transition. And what happens during the transition is we say, okay, we're going to say we're building our transition. If you use Java, it's like a builder. We're going to say, okay, the duration is going to be a second, and what's going to happen over that second is the width is going to change to this and the height to that. Once again, WH transform, that's a function. We're going to scale the value of that data by 1.5, append px to it so we know we're dealing with pixels, and that's going to become the width and height. All right, so now we have more squares, more Fibonacci. Let's move on to the next level. The next level is real-time streaming data with WebSockets. It's going to be a big jump. But bigger than that is going to be that we're going to see data changing. We're going to see data leaving the stage for the first time. And we're going to have structure with Backbone. But I'll get to that in a second. So actually, you know what? I'm going to reverse that around. Let's first understand this chart, then let's look at the big structure, then we'll drill down to the details. So this chart works a little differently than the other ones. What you're seeing right now is the plotting of random XY coordinates in this plane over here. And our visualization is structured so that we only ever see 10 at once. When new data comes in, after we hit the 10 threshold, the oldest data point gets shifted off and disappears into space. So when we have more complicated animations here, we have an enter animation and what D3 calls an exit animation. The exit animation is a square turning yellow and fading out. The enter animation is a square enlarging, just like it did in the last one. And once again, these are just divs on a page. You're just manipulating the DOM through all this. So let's look at how we structured this. By show of hands, how many people here have used Backbone.js? How many people are familiar with it? Okay, a lot of people. I'm glad that there's so many people because those of you who don't know Backbone are going to be a little left out. But if you have MVC knowledge, you are going to understand a lot of it. So let's look at the high-level structure of our code. This is the code that runs on document ready. And this is kind of wraps up the whole idea of how we visualize real-time data sets with Backbone and D3 before we had no Backbone. So the first object we have here is a custom one I've made called number stream. And what that is it represents the WebSocket that we're streaming these from. We have a backend web service that's streaming numbers to it. And the first thing I like to do with WebSockets and Backbone is wrap them. Because the WebSockets interface is very W3-ish. It's like you don't want to deal with it. And it doesn't play well with Backbone. Like you assign a callback to an event. You don't get two callbacks. You're done. So this is just a simple class. It extends Backbone events, and it just wraps all those functions, and it bubbles up events using Backbone events. And it also does some things like it checks if you're on Firefox, and it'll do the right thing there because it has a weirdly named WebSocket object. And it does one other little thing, which I guess you could argue doesn't belong here, which is it parses the data that comes with the WebSocket. It's a string with 2 points at the space between them. It just splits them on the space. Bubbles that event up. Okay, so what do we do with that? Well, we feed it into a model. So as I said before, all data in D3 is in an array. So our model is tasked with maintaining that array. All the visualizations have to be is an array. It doesn't understand anything else. So our model is going to do this. It's going to hook in to our WebSocket, and every time it gets new data, it's going to maintain that rule of 10 we had. It's going to receive a new number, it's going to add it to the list, and it's going to take off the first number if there's more than 10. So we're just maintaining a list, a sliding window of numbers, going through whatever random sequence we're in. The last part is, and we can see we're doing things in, I guess, kind of a DI style. We're passing in the stream explicitly. And And that's our model. So here's our weird WebSocket event object. Here's our model. And here's our view. And we're going to pass the model into our view. All the action happens in the view. So the great thing about this is it separates our concerns really well. Backbone plays really well with it. Because remember, D3 is about taking your data and visualizing it using the DOM. It really fits well with D3. So let's look at some of the high-level ways we'd organize that in Backbone code real quick. Well, our model is pretty simple. That's this guy. We got number sequence, yeah. Number sequence, poorly named. Number sequence is our model. And all it does is it, let's see. Where do we hook into that? Here we go. Stream.on, right? We're binding to the event point, and we're taking that point, and we're just maintaining that array. I mean, I'm not going to go through this code. It's kind of boring. But the main thing to know is it maintains that array, and it does one really special thing, which is since we have changing data, D3 needs to know which data is what, which data goes to which DOM element. Because you're passing through these arrays, it needs to know that, okay, is that div already on the page? Have I rendered that before? Is this old data that it's not going to be entered anymore? It's leaving? Is it coming? I don't know. So we're going to make a pretty rich data structure. We're going to make this one. We're going to actually save everything in an array that is maybe poorly formatted, maybe not. The first argument is pretty much a UUID. I'm using the timestamp, which is sloppy, but this isn't a distributed system. No one cares. The second one is the actual XY coordinate. So we're going to use that timestamp as a number that D3 can go back to and figure out what's going on. So I've kept on mentioning select all, that magic thing that I won't tell you what it does. What that does is it says, this is the stuff on the page that you're going to be graphing, and when you pass in new data, it cross-references it with the data you passed in and says, okay, I know this div tracks this unique element, so I'm not going to redo the enter event for it because it's already happened. So that's important here because a random number could appear twice. You can't do it based on numerical identity. You can't do it on array position because the array positions are all changing. So real quick, here's what happens here. When we call data over here, we give it a second argument, the identity function, that returns that timestamp. That's how D3 knows that it's a new piece of data and what data is what. The select all, like I said, black magic binding data to DOM elements based on that identity function. If you don't have one, by the way, it's implicitly the position in the array. Okay, so let's look at our fancy exit function. So we have more structured code here, you might notice. When we initialize our view, the first thing we do is we create we create that initial root viz element. We don't need to redo it after that. What we do on render, do need to redo on every render, is define the enter and exit transitions. So those are pretty simple. Well, you can use our knowledge and kind of read through these a little quicker now. You can say, okay, when new data comes in, what do? We append a div. We kick off a transition that's going to last half a second. We're going to hard code the width and height to 10 pixels, which is, by the way, you could have just done this in CSS. It's probably better than doing it this way. Because remember, these are divs. You can use CSS on them. Then we're going to style it on the top and left with this function. And lastly, and that's it. We're just drawing simple squares. You don't have them doing that much this time. And the last thing we're going to do is we're going to define this exit function over here. That says this is we're going to find what happens when data leaves the data set. And we're going to style the background color yellow. We're going to kick off another transition for a half second. And we're going to fade it out, opacity 0. And the last thing we're going to do is remove it from the DOM. And that's kind of as much as I want to talk to you guys about D3 because I think there's a good bit here. But the main thing to realize is you're just manipulating DOM elements. You have ultimate control here. You have a toolkit with a lot of helpers I haven't gone into to help you build charts because I don't think I have the time to build any chart you want and visualize data any way you want. And I think that's kind of the ultimate solution because anyone who's used charting frameworks knows how painful they can be. Anyway, I hope you guys enjoyed the talk. If you have any questions, I'd be glad to take them. Any questions or go for it?
How does D3 work with Canvas?
So not very well. Not at all, actually, as far as I know. I mean, you can do anything you want. But the thing with Canvas is you're drawing pixels in a buffer. You could, I guess, you could manipulate. So the thing you can do with Canvas is have multiple Canvas elements and overlay them and do stuff like that. You could do that. It's really against the spirit of D3. If you want more advanced stuff, use SVG. A lot of the examples I showed you actually use SVG. I stuck to divs here because they work a lot of the time. But for really smooth animations, for like complicated things and like Beziers, you have to use SVG. And usually with Canvas, you wind up hitting a wall. The thing with Canvas is you can paint yourself into corners. You realize that there's stuff you can do with like a pixel buffer that you can theoretically do anything, but practically you don't have time to. So I think it's really wise to stay to the DOM, especially with real-time data, because you're constantly modifying old data usually. You're modifying old representations of it, and that gets awkward with Canvas. So that's my thoughts as far as that goes. Any other questions? No?
So you said you could set the width and height in CSS instead of using the D3
Yes.
commands, and the invisibility to opacity. How's that controlled? Is that just part of transition, or would it just show up automatically at 10 by 10 if you had CSS?
Well, first off, I have been using CSS this whole time. I just highlighted actually. Sorry, I forgot to mention that. So as you can see here, like the blue in these squares right now, that's actually defined here. I think there was a part of your question I missed. Can you go back to what did I miss?
Oh, just if you use CSS, then when you append the div to that, doesn't it just show up with that full CSS styling?
It does. It definitely does. So if you have something like, if you want your div to fade in, you have to, and it's set to display block and opacity 1, then it's going to show up instantly. So what you'd have to do, but remember, anything you set here is going to be set as an element level attribute, so it'll override the CSS generally, unless you have, I guess, important. So if you change an attribute in D3, it'll usually have precedence, unless there's something really weird going on. I think there was one other question. No? Yo. Look how many of these little guys there are. There's tons of them all over the place. Doing all kinds of stuff. It's pretty good. I mean, well, you have control over the DOM. So performance is almost up to you. The only performance consideration D3 actually has is executing JavaScript. It's just directly modifying DOM elements. You know, when you append when you have new data coming in, you know, it's smart enough to do some housekeeping for you, like it doesn't re-render DOM elements. You know, when you have new data coming in, it just keeps the old ones around. That's what that magic select all thing does. So it can degrade if you do bad things with the DOM. If you have a lot of opaque stuff, does that answer your question? I don't know if I'm going too far on this. If you have more detail, I'd be glad to give it a try. Or maybe shoot up an email to Mike Bostock if not enough time here for that. But cool. Any others? Cool. Well, thank you very much. I enjoyed presenting to you guys, and I look forward to the next talk. Thanks.